Dear students, I'm Mahesh Javalkar from Maratha Polytechnic. Today I'll be posting my second video on Dcet questions on digital communication. In my first video, I have sent around 20 questions on digital communication. Now I will be sending another 20 questions. So we'll start with the 21st question. Okay. So the 21st question says that what is the minimum bandwidth required? Okay, what is the minimum bandwidth required to transmit a 56 kilobit signal with no noise? Okay, now for this question, the formula what we can use is your channel capacity is equal to twice the bandwidth. Okay, and if you ask bandwidth, bandwidth will be equal to what is the signal channel and upon 2. Okay, so here the channel capacity or the signal is given as 56,000, that is 56 kilobits per second. So 56,000 upon 2. So here nothing but B will be equal to around 28,000. So in terms of frequency, it will be given as 28 kilohertz. Clear? So here the bandwidth, the minimum bandwidth without noise will be around 28 kilohertz. So here the option will be option B, 28 kilohertz. Okay. Then we'll go to the next question. Question number 22. Which of the following is not a binary code? Okay, now here the options are your option A is Morse code, option B is automatic repeat request code, where the data is again repeatedly automatically it is given if there is an error found. Then C is baud out and D is CCITT2. Now in this B, C and D, these three option uses binary data, whereas the first one, Morse code, uses space and dot. So the Morse word is one which is not using a binary code. So option A will be correct one. Which of the following is not a binary code? So Morse code is not a binary code. Okay. Then we'll go to the next question. Question number 23. Bit errors in data transmission are usually caused by. Okay. Now in data transmission, a bit errors means a bit 1 can become 0 or 0 can become 1. A wrong bit is been recovered at the receiver, and that is mostly done by noise. That is not done mostly by equipment failures or typing mistakes or worse signal to noise ratio at the receiver. It is mostly done, it mostly happens because of noise. So here the option B will be correct. Bit errors in data transmission are usually caused by noise. Okay. Then we'll go to the next question. Question number 24. Another name for parity is. Okay. Now parity means the number of ones in a given data. If the number of ones in a given data are odd, then it is odd parity. If number of ones in a given data is even, then it is even parity. Okay. Now this is another name for a method called as vertical redundancy check, VRC. So, okay, so VRC can also be called as parity check method. So there, here the option will be option A, vertical redundancy check. Okay. Then we will go to question number 25. The building block of a parity or BCC generator is what? Okay. Now, a parity generator can be developed by using a basic exclusive OR gate. Exclusive OR gate is one which can help you to give whether a data is having number of odd parity or even parity. So here the option will be XOR, C XOR. The building block of a parity or BCC generator is XOR gates. Okay. Then we'll go to the next question. Question number 26. A longitudinal redundancy check, LRC, produces block check character or cyclic redundancy check or parity bit or error detection. Like in this, it will be the first option, that is block check character, because in that block only we are going to see whether there are number of ones are odd or even. Okay, and with that we are going to have parities. Okay, so a longitudinal redundancy check produces a block check character. Option A will be the correct option. LRC produces block check character. Then we'll go to the next question, question number 27. Dividing the data block by a constant produces a remainder. That remainder is used in the receiver for error detection. This method is called as what? Okay. Now here what we are doing, we are going to take a data, divide it by a known constant, then you get a remainder. That remainder you send to the receiver, and in the receiver also, when you receive the data, divide it by the same constant what you had divided by in the transmitter, and there also you will get a remainder. If both the remainders are same, then there is no error. But if both the remainders are different, then there is an error happening. This method is used in cyclic redundancy check. So here the option will be cyclic redundancy check, option D. Okay. So dividing the data block by a constant produces a remainder, and that remainder is used at the receiver for error detection. And this method is used in a method called a CRC, cyclic redundancy check. Then we'll go to the next question, question number 28. A CRC generator uses which components? Okay, now if you remember the CRC diagram, okay, now in that, whenever the data enters the block diagram, the data is shifted from one shift register to another shift register. So here shift registers are used in CRC generator. So the option C will be shift register. A CRC generator uses shift register. Then we'll go to the next question, question number 29. Data communication refers to the transmission of what? Transmission of voice, transmission of computer data, transmission of video, or all the above. Okay. Now here, if you see voice, voice will be an analog signal. Okay. And your computer data will be your binary data. So voice, if you represent, you are representing voice as an analog signal, and if you are representing computer data, then it will be 1 0 1 0 in that way, binary, that is 1 0 1 0 and all. And if you see video, video also will be an analog data. Okay, and the fourth option is all the above. So here I think the data communication means bits per second. Bits per second means you should have binary data, ones and zeros. So it is the option B, computer data, which is correct. So here data communication refers to the transmission of computer data, which gives you the bits per second, and that is what is data communication. Okay, then we'll go to the next question, question number 30. Data communication uses, the first one is analog method, second one is digital methods, third one is either of the above, and fourth one is neither of the above. So here obviously data communication is using your binary data, and binary is a boolean function, either yes or no, true or false. Okay, so and for that you are using digital methods only. There are no analog methods there. So here the option should be B, data communication uses digital methods. Okay. Then we'll go to the next question, question number 31. The number of amplitude, frequency, or phase changes that take place per second is known as. Now here, if you want to change amplitude, the number of amplitudes, if you want to change number of frequency, if you want to change number of phase, that itself says that you're changing some symbols. So if you're having a symbols per second, if you're having something called as symbols per second, then it is called as baud rate. Then here the option will be option D, which is called as baud rate. Baud rate is nothing but symbols per second, and here symbols can be a number of amplitude or frequency or phase changes that takes place per second. Symbols per second is called as baud rate, and bits per second is called as bit rate. So here it is symbols per second, so it is baud rate. So option D will be the correct answer. Then we'll go to the next question, question number 32. Which of the following statement is correct? The bit rate may be greater than the baud rate, or the baud rate may be greater than the bit rate, or the bit rate and baud rates are always the same. The bit and baud rates are not related. So obviously the first one, bit rate may be greater than the baud rate, because baud rate are symbols per second, and every symbol can be a set of bits. So automatically bit rates will be more. So bit rate may be greater than the baud rate. The first statement will be the correct one. Then we'll go to the next question, question number 33. Transmitting the data signal directly over the medium is referred as. If you're transmitting the data signal, the information signal directly over the medium, that means you're transmitting the basic signal without any modulation. So it is called as baseband transmission. So here option A will be correct one. Transmitting the data signal directly over the medium is called as baseband transmission. Okay, you are not doing any type of modulation over here. It is only the basic signal which are going to transmit from the transmitter to receiver. Okay, then we'll go to the next question. Question number 34. Sampling theorem is associated with what? Pulse code modulation, frequency modulation, amplitude modulation, or all of the above? Obviously, option A will be the correct one, pulse code modulation, where we are converting analog signal into digital. And while converting analog signal into digital, first we have to make samples of the analog signal, and then you have to quantize them. Sampling and quantization are the two processes. So in sampling, sampling theorem is used. The number of samples per second, that is sampling frequency, Fs, should be at least or greater than equal to twice the highest modulating frequencies. So here the option is first one, PCM, pulse code modulation. Okay, sampling theorem is used in pulse code modulation. Then we'll go to the next question, question number 35. In pulse modulation, the number of samples required to ensure no loss of information takes place. Okay, no loss of information takes place. So that can be done by saying that the sampling frequency Fs is equal to twice the highest modulating frequency to Fm, and this condition is nothing but called as Nyquist criteria. So this basis of sampling theorem is also called as Nyquist theorem. So in pulse modulation, the number of samples required to ensure no loss of information is given by Nyquist theorem, where Nyquist theorem says that is the sampling frequency Fs should be at least equal to twice the highest modulating frequency, so that from these samples you can reconstruct the original signal back at the receiver. Okay, so this is your option A, Nyquist theorem. What is the option for this question? Okay, then we'll go to the next question, question number 36. With reference to sampling theorem, which of the following statements is correct? The statements are: the signal should be sampled at least twice each cycle at its highest frequency. Guard time should be as large as possible. The signal should be sampled at least twice each cycle at its lowest frequency. And D is Nyquist rate should be as slow as possible. So here the option A, what we have already seen in Nyquist criteria, the signal should be sampled at least twice each cycle at its highest modulating frequency. That will be your Nyquist condition. This is the basis of sampling theorem, and this statement is correct. The signal should be sampled at least twice each cycle at its highest frequency. Then we'll go to the next question, question number 37. Sampling an analog signal produces what? Sampling an analog signal produces what? So say if this is your analog signal. Okay, so here I will draw your analog signal. Okay, this is your analog signal. So here I can show you. This is the analog signal, and for this analog signals you can have this samples. Okay, so if you convert that analog signal, this can be your samples. Okay, so this can be your samples. Okay, so here you can see your analog signal. So this type of samples, if you produce like the samples, if you produce like the samples, then those will be called as pulse amplitude modulation. So sampling an analog signal produces pulse amplitude modulation, which is called as PAM. So here the option A will be correct, which is PAM, pulse amplitude modulation. Then we'll go to the next question, question number 38. Pulse amplitude modulation is a process whereby, okay, now in pulse amplitude modulation, the position of the pulse is not changed, the width of the pulse is not changed, the amplitude of the pulse is changed. That means the height of a pulse is changed. And here the option C will be the correct one. The height of a pulse is made proportional to the sampled value. Now, this is what happens in your pulse amplitude modulation, where the amplitude of the pulse is varied according to the instantaneous value of the information signal. Okay, so option C. So it is not position, it is not width, it is the amplitude, it is the height of a pulse which is made proportional. Okay, then we'll go to the next question, question number 39. Pulse position modulation signal can be generated from pulse width modulation signal by using what? Okay, now we know that pulse width modulation is a process where width of the pulses are varied according to the instantaneous value of information signal, and this can be done by using a comparator. In that comparator you can use two inputs, one is your signal and one is a ramp wave, and the output can be taken as a pulse width modulation. Okay, And in that pulse width modulation, that is PWM, width of the pulses are varied according to the information signal. Now those pulse width, the varied pulse widths, if you give to a monostable multivibrator, then that monostable multivibrator will produce pulses of constant width, but it will change its position. So you will get a ppm from PWM by using a monostable multivibrator. So here the answer will be monostable multivibrator, which will generate pulse position modulation from pulse width modulation. In pulse position modulation, the position of the pulses, keeping the amplitude and width of the pulse constant, the position of the pulse is varied according to the information signal, according to the instantaneous value of information signal. Then we'll go to the next question, question of 40. Which of the following pulse modulating system, which of the following pulse modulating system is analog? Now in this, we see the first one as pulse code modulation, second one as pulse width modulation, and third one as delta modulation, and fourth one as your adaptive delta modulation. Okay. So if you see analog, this thing, modulation, okay, in that you have PAM, PWM, and PPM. So, and the other, which are PCM, pulse code modulation, delta modulation, and adaptive delta modulation, are getting you the digital values. Okay, so the first uh, analog modulating, that is pulse modulating systems which are analog, can be PAM, PWM, and PPM. And out of this, the option which is there in this ABCD is option B, that is pulse width modulation is analog. Rest all are not analog, they are digital. So here option B will be the correct answer, that is PWM, pulse width modulation. Okay. So these are another 20 questions what I've taken on digital communication. And in my next video again I will release another 20 questions, so you can go through these questions. And always see that your fundamentals, your basics are clear of any subject, and for that you have to read a proper textbook, or you read the concept on the net, anything, but you should read the concept. And after reading the concept, see that whatever you assume, your assumptions go correct according to the electronic theory. And if your assumptions are correct, and if your basics are strong, then you can solve any type of multiple choice question. You can attempt any type of MCQ. Okay. So with this, I will end my video here. If you're having any doubts, you can call me, you can send me a message, or you can ask me. Okay. And see that you don't accumulate any basics doubts. Either first thing is your basics should be clear. Once your basics are clear, then the other derivations and the other higher things you can easily develop, because your basics will be strong. If your foundation is strong, you can develop anything afterwards. Okay. So I will end my video here. Thank you very much.